In number 39, we're again asked to subtract, but what's different this time is that the denominators are not the same. We will still change the subtraction into adding the opposite, but in order to get these denominators to be the same, we must look at the factors of each denominator. In the first fraction, 2x over x plus 2x minus 2. Remember, that's the difference of squares, x squared minus 4, and it factors into these conjugates, plus negative 1 over x plus 2. The LCD is what we want to use to build up the fractions, and the LCD must have a factor of x plus 2, and because of the first fraction, x minus 2. The second fraction already has the x plus 2, but obviously it's missing the x minus 2, so that's exactly what we're going to multiply this fraction by, both numerator and denominator. X minus 2 over x minus 2. Fortunately, the first fraction does not need to be built up. It's fine just as it is. As we get ready to combine these, notice that the negative 1 here will distribute through to each of these. Let's see what we get. 2x over the x plus 2 times x minus 2 plus, in this numerator, a negative x and a plus 2, again over x plus 2, x minus 2. Because they now have the same denominator, x plus 2, x minus 2, we can combine them into a single fraction, 2x plus a negative x plus 2. Now we can simplify the numerator. That becomes x plus 2 over x plus 2 times x minus 2. And you probably already see what is about to happen, and that is that the x plus 2 in the numerator is the only factor we have. When we divide it out, we're left with a 1 in the numerator and 1 in the denominator, and the end resulting fraction is 1 over x minus 2. In number 40, we have to add the fractions, and it's similar to 39 in that the denominators, they're not the same. And so we have to discover what the LCD is, and we're going to do so by factoring them. Factoring the denominators only, x plus 2 over x times x plus 1. We just factor out an x. Plus x plus 4 over, this time we'll factor out 3 times x plus 1. Now in this case, our least common denominator, LCD, must include an x and an x plus 1 from the first fraction. And let's see, the second fraction must have a 3, and we don't have that yet, so let's include that in the LCD, and must have the x plus 1, which is here already. So we need to have an LCD of 3x times x plus 1. That means that we're going to multiply the first fraction by what's missing from that LCD, and it appears to be missing the 3. So I'm going to multiply this by 3 over 3. And that'll multiply directly in the numerator as well as the denominator. And in the second fraction, we are missing the factor of x from the LCD. So we're going to multiply by x over x. And in the numerator, I'll put that in parentheses because just like with the 3, we really are going to be distributing. That is the 3 being distributed, and then likewise with the x. So let's see what we've got here. In the first fraction, we now have a 3x plus 6, and in the denominator, 3 times x plus 1. Plus, in the second numerator, we distribute the x and get x squared plus 4x. The denominator, though, is the same now, 3x times x plus 1. Eventually, we're going to have to factor the numerators, but not yet. The reason we don't want to factor these numerators yet is because they still need to combine like terms. So we're going to write this as one fraction. In the numerator, we have 3x plus 6 plus x squared plus 4x, and combining like terms and putting it in descending order, that's x squared plus 7x plus 6, all divided by 3x times x plus 1. Now that we have it as a single numerator, all combined and simplified, let's see if we can factor this. You can use the factor game to show that this numerator factors into x plus 6 times x plus 1. And it's still being divided by 3x times x plus 1. Finally, we're to the point where we can divide out common factors. So we divide out x plus 1, we're left with 1 there and in the denominator as well. And what we get as a result is x plus 6 in the numerator and 3x in the denominator. Again, nothing at this point can divide out because we cannot divide out terms, we can only divide out factors. So we can't divide out the x's and so on.